Hello, hello. Can you hear us at the back? Hooray! Hello, we are the Land Gardeners. I'm Henrietta Courtauld.
And I'm Bridget Elworthy, and we're here today to talk about how to feed your soil. And we've got maybe 15 minutes, so hold on to your seats. We're going to absolutely rip you around the world looking at different ways of feeding the soil. And of course, thank goodness, following us, you're going to actually have a real-life, amazing Canterbury farmer, Simon Osborne, to tell you exactly how he dives deep into his soil and feeds it. And we've been at his farm. It is truly remarkable. And so you hold tight. We'll skate you through the first bit, then you'll have some wonderful words of wisdom from Simon.
It's rather like we're his backing group, so this is the warm-up act to the main singer.
Okay, so
we're going to start first of all by telling you a little bit about our journey. We were both lawyers actually many moons ago, which seems slightly incredible now looking back. And then we both went into garden design and landscape design, and gradually became starting to look for something more.
In the interim, and my husband and I moved back to New Zealand because my father-in-law died, and we took over a family farm in South Canterbury. And I remember the first time going into a board meeting with a lot of men around a big table and being told to sort of keep my mouth shut because, of course, at that point I was quite alternative and still am. But I remember looking down the columns and seeing, oh, my goodness, we're spending a lot on fertiliser. By the way, this was about 20 years ago. A lot on fertiliser and a lot on animal health. And I kept flipping back and forwards thinking, well, if the fertiliser's working, why are the animals still unwell? And I thought there's something going on here, even though everyone was telling us we had this great farm that was really producing. And I remember saying to our farm manager in the meeting, what's going on? And he said, look, I lie awake at night worrying about it because everyone's telling me we've got everything right here. But I know as soon as the animals get stressed, they lose condition really quickly. So he said, I'm thinking of putting vitamin bolus in the water troughs. I'm thinking, this can't be right. There has to be another way. So when I came back to England and we started our business together, we started thinking there has to be another solution, and we're going to start from the ground up, looking at the soil.
So our children were at nursery school together, and while most mothers and fathers were hanging around at the school gate discussing play dates, we were discussing soil and have discussed it ever since and become totally obsessed. We decided that the best way was for us to get our hands in the soil and to actually start growing. So we set up a flower business up in Oxfordshire, where Bridget was living, and started growing organic cut flowers. And shamefully in the UK, that it's such a small market. So much is actually imported from Holland. Most of it is sprayed. It's huge, very stiff, very unbeautiful flowers, actually. And we really wanted to show that you could grow really beautiful flowers, homegrown and without chemicals.
But really, behind the scenes, even though we were producing a lot of flowers, actually what we were doing is we were going around the UK, around Europe, and around the world, trying to find out who was doing the best practices when it comes to feeding soil. And, we had these amazing, we've been at, in fact, I saw Darren Doherty today, and, I think 20 years ago I was at one of his courses with another guy from Mass Humus who was looking at chromatography and biofertilizers. And as the years went by, there was lots of experimenting, lots of, kids' goggles on our eyes as we made potions. But in the end, we came across a couple in Austria who were making a compost, an aerobic compost that really resonated.
Yes, they had learnt it from their parents, who'd learnt it from Pfeiffer, who in turn had learnt it from Steiner. And it's an aerobic composting method, and we'll scoot through it today. But if any of you want to talk about it in more detail, then do come to us afterwards.
I mean, there's many ways to feed the soil, and actually, as those 20 years have gone on, more and more we're thinking this method of composting that we're using is just one of many, many ways. As you all know, there's more life in a teaspoon of soil, so there's as much ways of feeding that life it's not just one way.
And it's about diversity. And it's our gut, isn't it? It's this huge digestive system that we are feeding, just as we're doing that ourselves now. We're so much more conscious of that for ourselves, looking after our guts for our own health. So that's what we're now thinking about when we're feeding the soil.
Okay, so Climate Compost was born, very similar to probably most of the compost that you're all making. Now, actually, it would just be interesting to know who is making compost in the room. Oh, bravo! What a group!
God, it's much better on this side of the world.
Who's making Johnson Sue? Brilliant.
Okay.
Who is using microbes or EM Bokashi? Great! God, what a fabulous crowd!
Any vermicast?
Oh,
great! Okay.
And what about biodynamics? Oh, God, you guys are just...
you're top of the class.
Top of the class. This is brilliant. Okay, so what we're going to do is, the way that we make the compost, we're going to zip through that. And basically, you all know that we layer up carbon and nitrogen, greens and browns. And the key to the compost that we're doing is adding clay.
Yes, so clay has a negative cation exchange. So it attracts the minerals, which are positive. And it has a huge, huge surface area. If you take a little centimetre, a cube of clay, and unwrapped it, it would be the size of a football pitch. So there's all those little nooks and crannies for microbes to connect with. So it really has been a game changer. You don't need to add much in your compost. Often what we were doing is digging, like when we were digging for a pond, or we'd get a bucket of clay, we'd dry it out, and then we'd sprinkle it over the top of the compost. Just adding tiny amounts has really been a game changer.
And also there's bentonite clay. If you can't get clay, just like sprinkling of that is really wonderful. Now, aren't we lucky to have such a nice man helping us? At this point, we'd be really losing the plot. Anyway, this is great.
So what you're really doing is thinking about it's a bit like a teenage party, a compost heap. You need oxygen, so you need to have the windows open so they don't all get too hot. They need to have some food, so that's why you're giving the carbon and the nitrogen. And they need to have some moisture. You need to give them something to drink. And if you've got, but not too much actually. But if you've got that the whole time, then those microbes will really start dancing. They'll start really humming together, and you'll start to get that energy in your compost really starting to work.
We're almost there, apparently. Well, it's going to be great, 'cause just you wait and see what this compost looks like after 6 to 8 weeks. Yes.
Would biochar be an alternative to clay?
Yes, it's a brilliant alternative. Yeah, and both is even better.
Yeah, we have put biochar in our compost.
Okay, so 6 to 8 weeks. This is what it looks like. I'm sure a lot of you have got compost piles that still look pretty similar after a year. But this is an amazing way of making compost. Now, we've tried to look at every way of making compost so that we don't have to do this. It's quite a lot of work. But the residue of what you get in this compost making is an incredible catalyst to sit at the bottom of all your other additives. So we are keeping going and making this. But there are lots of ways of making compost. And all of you, bravo, whatever you're doing is commendable. And as long as your compost looks like 70% chocolate, you're on track.
So we were doing it in little windrows, which we were turning every morning for a couple of weeks to get the air in them. But you have the brilliant Kay Baxter here in New Zealand, and she developed this, what we call compost cakes. So we wrote about her compost cakes in our book, and really these are really simple ways of layering your carbon and nitrogen into what looks like, as you can see, it's a bit like a cake. We sort of likened it a bit to a Victoria sponge, with big bits of sponge and then your cream and your jam as you layer your big bits of carbon, slightly less of nitrogen, and then these layers of clay and other amendments.
Anyway, Kay has got an amazing website and is an amazing source of information. So that is a static method that takes 4 to 6 months, also producing brilliant stuff at the end. Also, another big thing that we use a lot of is we started realizing that actually live composting is really brilliant, using lots of green manures and inoculating the seed with our compost, and then using this to cover the soils, buckwheat, phacelia, mustard, interplanting it between our flower rows, and so we were, pushing it over as a live mulch. It was also feeding the soil.
Yeah, the more biodiversity we had, the better the garden performed. We were mixing flowers and herbs and fruit, and as Bridget says, these green manures, and that wonderful biodiversity above ground was then feeding that biodiversity below ground.
There's always that question of should it be no dig or not. Ideally, it is no dig, but if you're starting with really compacted soil, the brilliant thing is to get some air into that. That's not necessarily meaning you've got to double dig or turn the whole thing over, or in a farm sense, ploughing. It's about getting air in. And if you do that right at the beginning, then grow green manures along with your additives, whatever they might be, Johnson Sioux or compost, you can see things thrive. So we're using, we use a broad fork in the UK, but I know Kay Baxter has a brilliant, actually it's Roebuck, and in fact I've just bought one over here, Jodie Roebuck's amazing broad fork, and it's absolutely game-changing. In fact, if I only had one tool ever, it would be a broad fork. Anyway, lots of different ways, plant teas, the Koro Kai, who were talking earlier. I mean, there's so many ways of making brews to feed foliar feeds on plants. It's anyway, whatever happened is we managed to raise our carbon from 5%, which is pretty good if you're looking at most farms, on a 30-acre horticultural unit, from 5% to between 12 and 15%. At that point, everyone thought we were sort of the kooky witches on the hill. The carbon scientists started coming to us and saying, how do you do this? This takes 100 years. And then the soil tests were coming back and they were going, no one in the UK gets these results. This looks like something from, the Netherlands or from Denmark. So suddenly we had a lot of attention. And we thought what we'd done at a horticultural scale, we would want to scale up to a farm scale.
So there are these brilliant thing called innovative farmer trials in the UK. You probably have similar ones here, where a series of different farmers come together and then they all trial the same method and they're overseen by a scientist. And it's quite a quick way, because we all know those scientific trials can take many years and be very expensive. It's a very quick way of getting some good results. And we even partnered with an island off Mozambique who hadn't been able to grow vegetables. And what they did is they took banana leaves and they took goat's poo and they made our compost windrows, and we kept talking to them and coaching them through it. And they created fabulous compost, and now the villagers are now growing their own vegetables. So that was a really rewarding moment.
And we tried it both in the north. We had people in Sweden. We had it in the south. We had people in New Zealand, all trying the same method. The only thing that we noted is that there's a certain time of the year, whether you're on the equator or you're up near the North Pole, where the microbes go dormant. So we sort of thought, we could be making this year round down by the equator, when there's the rains, then there's a dormancy. Anyway, so then we started thinking, okay, let's try this at scale. And we started going on some farms and turning their farm waste, which obviously is a little different in UK because a lot of the animals inside. And we started scaling up and looking at ways of then getting it out on the land. At this point, we didn't know about Chaos Springs, and obviously we were trying to make our own Chaos sprayers. We were trying to make our own sprayers. I think one of your units actually are on here.
We've now
Steve.
thankfully imported one.
Yeah, much better. But anyway, on this particular experiment in Northamptonshire, we turned some arable land that had been cropped for 7 years straight, that was completely sort of tired. And in one growing season, we managed to really revive it. And it was a drought that year. And the 250 acres, there was a sort of emerald square of green and a whole sea of brown in Northamptonshire. And at that point, once again, the farmers started standing around the outside saying, can we have that for silage? And what are you girls doing? And so so then we've teamed up with, we've found some farms. We've gone around all of the UK finding the best practitioners in 5 different disciplines: aerobic composting, biodynamics, Johnson Sioux, vermicast, and
Korean natural farming.
microbes. So putting all those different ferments together. And we have teamed them up with scientists, and we are now on a 5-year scale experiment looking at how, at scale, can you feed the soil. So look on our website, we'll be doing reports on that. But in the meantime, we thought, golly, this is not going fast enough. How can we get the population to demand that we look after soil?
So we thought, how can we raise awareness about soil? And we thought, an art exhibition. Let's have an art exhibition in the centre of London and take soil right into a main gallery. And amazingly, we went to a gallery and we suggested it. And amazingly, they said yes and that we could curate it. So we spent 2 years planning it. And it was this time last year. It lasted 3 months and we had over, 50,000 visiting it. And it really helped to just raise awareness, showing through films and art. And we're going to talk a lot about that tomorrow, if anyone's interested.
And at the end of the exhibition, we did this big installation of hope, because what we didn't want, we had a lot of youth going through, and there's a lot of climate anxiety. We wanted to say that actually soil is a source of hope. And in fact, there's quite a lot of people on that map from this tent and from New Zealand who are doing wonderful things with soil. There's also people who are in, horticulture, farming, viticulture, composting, who have made it onto this map, and you can find that on our website. We'll chat a bit more about that tomorrow. But here's just a few of them, just to help make you see, fill you with hope.
Yes, and if you want to connect with them, they're all on our map. So Kay Baxter, we spoke about her earlier. Bridget spoke to me about her for years before I met her, and that was a real privilege meeting her, because she does have an incredible connection with the soil and is experimenting in such an interesting way.
And she's such a quiet creature that, she doesn't shout about it, but honestly, if you sit at her feet and listen, every year there is something new. I mean, talking about curious and curiosity that was discussed this morning, she is endlessly curious, and every single year she's moving forward. A brilliant woman.
In fact, we talk a lot, I have to say, in England about Kiwis. And the other one we talk about is Steve Erickson. And just like when you go to Kay, you go to Steve's farm and you just feel the energy. It is palpable, this incredible energy that is pulsating through his farm, and the growth and the vitality. He has wonderful resources on his website.
Yeah. We often say that, when we describe, when it's actually not in New Zealand, when we're talking about him, we say it's like when you go to visit his farm, it's a little bit like having one step into heaven, which I hope heaven's like. Yeah. Because, it's shiny. There's something shiny. And we often talk about Weller hair. Those Weller hair ads when they're flicking their hair around and everything's shiny and not sort of haggy hair, but Weller hair. Anyway, that's Steve's farm. And you really feel the energy. And I think that is one of the big things. We've talked a lot, over the years about the chemical makeup of soil. And then, of course, we all got very excited about the biological makeup of soil. But having done this exhibition and having ourselves, we're biodynamic practitioners, we realise that actually the real key is the energetic quotient of soil. And I'm sure all of you, in your own way, and because you seem all highly evolved in this tent, you can feel that energy, and you also know that that's coming from you. And I think that's, the point of all of this is that it actually comes back to you and your energetic, your vibe, I suppose, but your energetic connection to the soil. And the more you can foster that, the more that dance will happen, and it will be very fruitful. And I think a lot more is going to be just, this is going to come up a lot more. We've got this incredible biodynamic tent here, and I think all of you need to sign up and become full members, because I swear to you, in 5 years' time when we're back here, we're all going to be talking energetics and physics.
And of course, that links so much to the Maori, that wonderful talk this morning.
Yeah,
those principles are the same. For me particularly, that was really interesting, hearing about the indigenous practices, because, again, it's that energy, it's that rhythm
Yeah. So tomorrow, Steve is speaking about quantum agriculture and radionics and all this sort of stuff, which is so mind-blowing. So I'm sure you'll all be here for that tomorrow.
Okay, the time's up. So, Graham Sate in Australia. Sure, most of you know about Graham Sate, but he is so generous with his information. So look at his podcast.
Nutritech Solutions, Google it. There's also someone called Rhonda and Bill Daly who are doing amazing things with this microbial compost like we do, but they're also adding minerals in. They're making up IBCs of potions, like almost prescription potions for farmers, and sending them out and getting unbelievable results in a very difficult environment. There's also, in India, we went to see Vandana Shiva's farm and looked at how they're using vermicast and all sorts of seed.
Owen Goltz is an amazing farmer in Canada. He's really focuses on self-sufficiency. He's looking actually at the metabolomic template. So he's looking at the metabolites in a plant, and if he can alter those by how he grows his plants, how he treats the soil, and in turn, how does that affect the health of humans when they eat those plants? So he's really interesting, using a lot of biochar, a really simple machine to make wood vinegar, which he uses a lot on his farm.
And then there's someone called Christoph Fischer in Germany who's doing wonderful things with microbes, from, things to feed your soil, to clean your house, to clean your hair. But he is also trying to develop ways to grow crops. I mean, he's getting wonderful results with his root growth and things. He does wonderful bokashi piles, when you're packing up bedding, and then they're growing
green
manures on top, so that you can't actually you can't see the piles because the government won't let you have piles of manure sitting there. But it's also that green manure is breaking down the compost as it goes. If you ever have animals inside, or if you've got dairy cows, there's a fine mist. He mists out these microbes onto the cows. They breathe them up. They're getting better lungs, better skin health, and also it's getting into their poop and it's going out into the slurries. And then it's like, how does he basically do cropping without glyphosate? So he is managing to do this in a way where he is using this type of aerator, which he pumps down microbes through this little tube. And he he direct drills green manures, and then he comes along, he chops the green manure on the front, and on the back he's got this fermented process where he's spraying it on the chopped green manures. And then a week later, so that creates like a sort of self-composting mulch across the soil. Then a week later, 7 days later, he goes across with a direct drill and a squirter, and he puts the seed down through that mulch. And when that seed grows, this mulch is stopping a lot of the weed growth, and it's also protecting the soil and feeding the soil. So anyway, really sort of bad little pictures we've got of that. But it is, he's managing to grow crops without glyphosate. It's possible.
We've had really good results this winter, actually trialling on a farm using microbes where we had terrible compaction, and they have definitely improved. The field where we've used the microbes is much more open than the other fields. So
anyway, biodynamics, which we talked about, and Johnson Sioux. There's an amazing team of people up in the borders doing Johnson Sioux. They've got 50 different Johnson Siouxs on the go. They've got a 1,000-acre farm, and they are getting unbelievable results. And they've just set these Johnson Siouxs up in a row at an old barn, and we can tell you about that later. But of course, you had the Haggertys, I think, here last year, telling you how. Oh, they're at Grounded. Oh, well, we're going to see them next week, so we're going to do a little film. So watch our space. Watch our
the king and queen of Johnson Sioux. They
yeah.
are. This is wonderful. Tom Fairfax, who's a real experimental farmer up in the north of England. He has over 1,000 acres. He's been doing actually a trial with sheep and willow, finding that the boron levels in sheep improves having eaten the willow.
Cobalt, I think.
Yes, cobalt, sorry. Yeah, even.
But anyway, also the other thing is he's got an amazing way of making vermicast with buckets. A bucket system where he puts holes in the bottom of the feed buckets and he builds them up, and he have worms that start on the bottom and go up. And incredibly, he is then, and putting it on, because he's in Scotland, putting it on a heat pad, so if the temperature goes down below 5 degrees, he's making incredible vermicast that he then scales up through a sprayer. So anyone, it's a very simple system.
We're going to put that on our website because it's so cheap. I mean, that's the thing with some of these things. You can have big compost turners if that suits your farm, but you can do these really inexpensive methods. Joshua Sparks, he's a Korean natural. He has a farm. He's specialising in Korean natural farming, digging up microbes from his local woods and then using on his predominantly perennial farm, actually, with perennial vegetables and grasses. He's a really interesting man.
And, making all sorts of fish potions with layering, jaggery or sugar with fish guts and getting incredible results. So lots of things that you can do yourself. And then, of course, we were lucky enough to go to the biggest little farm last year, and the team there are really amazing. This is Sean and Alana from their fertility team, and my goodness, their fertility department is, honestly, we're so jealous.
Yeah.
Anyway, they have an amazing vermicast system where they have it, their vermicast in a long contraption where they cut the vermicast off from the bottom and they put that into their potions. You can see they've got a chaos sprayer, which is brilliant, that they love. They've also got a dynamizer, so they're working a lot with biodynamics. They have a whole biodynamic potion making room, and it's pretty interesting to see that they are looking at all the different, they're making composts, they're looking and using all these different methods of feeding the soil, and also teaching people how to do it, which is so impressive. Anyway.
Sorry, that was like a gallop through those. So if any of those are interesting, please come and talk with us if you want us to connect you with any of them, or go on our world map. And also we would love to learn from any of you that are doing these, because the more we can connect, and the more we can even connect across continents, we just feel we've got a better chance at really fighting against those terrible chemical companies.
Oh, okay. Now here's Simon Osborne, who really is an absolute dream, and he is going to tell you all about how he's feeding his soil in Leeston, Canterbury.
Well, thank you, Bridget and Henrietta. My goodness. Not sure I can keep the energy up that we have just experienced. I feel thoroughly inspired and... okay. Sorry about that. What about now? Kinda. Just give us a minute. So what do I do here? It's up there. Cool. Hi. Kind of a different pace and different flavour now. So I'm talking about myself, which is kind of weird, but anyway, or what we do actually, not talking about myself. But so I'll just hook straight into it. So I'm farming almost on the shores of Lake Ellesmere. Been a 280 hectare arable farmer with clay soils, which are wonderful in terms of holding that carbon, as Bridget and Henry mentioned. So we started no tillage in 1976, sort of moved to a conservation agriculture system in 1993, and started sort of active agri-system agri-ecosystem management in 2014. So my brain, I have to work through the way it works for me. So you'll just have to sort of get a bit of background on the logic I use when I think about farming and how I do things. So I guess first of all is identifying what it is we're talking about. So what is a healthy soil? What do we want? What do we want to do to produce what we need to produce? And so a healthy soil is a complex web of life powered by the sun and fed by plants. And there's all the other, obviously, microbes and arthropods and everything else that contribute to that. But that sort of clarifies where we start, what's our starting point. And I guess then we move on to, what is a plant, what is life, and that helps us to identify how we can work with the system and work with nature. So life begins on land about 1 billion years ago when cyanobacteria or algae form an association with fungi, which allows life to move from a wet environment to a dry environment, because the fungi can provide an architecture in which their photosynthetic colleagues can live, because obviously the fungi can't photosynthesize, and the algae and the cyanobacteria can't provide any architecture to live in out of moisture. So to me, the lichen is one of the most beautiful things on the planet. Really, it's our progenitor. We're all descended from this. So the photo on the left is of the old dairy yard at home, and it just shows I'm not sure whether you can see, but there's a wee bit of lichen growing on the concrete, and then the mosses sort of start to build soil. So the lichen sort of start to solubilize the geolith, the stone, the rock, and then in their bodies they mobilize nutrients, which gets a microbial activity going, creates a moist environment, and then higher plants over the last millennia have evolved, and then you've got the grasses, the rough grasses at the background. So that's sort of the progression of plants or life. So we'll start with the most important nutrient there is on the planet. Well, carbon, hydrogen and oxygen obviously are the most important things we have, and they make up the bulk of life. Well, they make up the bulk of life. There's about 2% of other things, but everything else is carbon, hydrogen and oxygen. So what do we need to do? We need to increase. Carbon is king. Carbon is always king in farming, and because it's lifting our carbon levels that allows us to have the energy in the soil to be able to support the life that we need to then that can then circulate the nutrients and create life. And the photo on the left is some wheat seedlings that were inoculated with EM and molasses, and they've already formed rhizosheath at probably a week after planting, which is fantastic, because they're going to they're exuding carbon from the roots, and that the microbes are building their house in that area on the rhizosheath essentially. So from a commercial farming point of view, how do we make sense of all this? And the first key is nutrient fertility management and mobilisation and availability. So you're looking at the fertility, the nutrients, but probably the mobilisation and availability are the key factors to start with. And there's a range of ways we can do that. There's obviously compost as fertility management and nutrients, but we use plants to mobilise nutrients in the soil. So here on the right-hand side is a cover crop that's been planted immediately after a wheat crop has been harvested, and so that's just a mixture of lupins, oats, crimson clover, phacelia, and whatever else we might want to put in. We might put some berseem clover or whatever. And on the crikey, I'm dyslexic, sorry. On the left is the sort of the cover crop type thing that we end up with, and that's both a rich nectar source, so it's feeding the insects, it's feeding the arthropods, feeding, and then the animals come and graze it. So after harvest, we'll give it a quick mulch, chuck some sheep in. They'll poo everywhere, so that's essentially our inoculant. Then we'll plant a cover crop that's building biomass under the soil. And I'm sorry, I'm going to have to go back to this one. The building carbon in the soil, I always thought when we started no-till, was putting material on the surface of the soil, and it would gradually be absorbed into the soil through bioturbation and what have you. But actually, since people like Nicole and Christine Jones started talking about Christine Jones started talking about the liquid carbon pathway, that's actually the quickest opportunity on a farm scale to get carbon into the soil. So hence the immediate establishment of cover crops after harvest. For us, companion cropping is another way of mobilising nutrients, suppressing weeds, and building a healthier farm ecosystem. So in this series of photos, we immediately after harvest, this was an experiment we did a few years ago, where we harvested a crop of peas, field peas, and then immediately planted Phacelia, crimson clover, and buckwheat into the paddock. And then the photo at the bottom shows inter-row planting wheat. So that would have been planted at the beginning of March, and then the wheat was planted at the beginning of May. And it was inter-row planted between the rows, and there was before we went in the machine with the machine, it was up to knee high, and I was sort of concerned that the wheat would be shaded out and wouldn't establish and all the rest of it. But actually what happened was, we had, as a control to that experiment, we had a one that was planted just in a stubble, and the one planted in the cover crop emerged about 10 days before the other one. And so soil temperatures are cold at that time of the year, and with wheat, getting it up and away is critical before it gets wet and cold, because then it's more susceptible to rotting or disease or whatever. That worked really, really well, but we needed to graze. We grazed that crop during the winter, and it was huge. And you need a lot of sheep, and you need them for a short time, and so it's not possible to do that over the whole farm. We just don't physically have enough animals available that we can do that with. But that required one herbicide for the whole crop, which is, compared to conventional, pretty dramatic reduction, and produced what I would call 100% yield on what we had. So that's a technique that we use. There's a range of ways we do it. Just a quick range of photos there showing what we do after harvest. There's mulching in the top right-hand corner, and then planting straight into that mulch. So we've got a layer of material there, insulating the soil, protecting it from the sun, protecting it from the rain, and providing a nice microclimate for slugs as well, which we have to manage occasionally, but not so much anymore. So you can, there's a couple of those photos of peas just planted into stubble, which they do very well. So that's sort of, I guess, just the fundamental things you do as farm management factors that aren't applying anything, or but then we move on, and I mean, we've all heard about Johnson Sue, so here it is. This is a few years ago. You might recognise the hairy bugger in the photos. Sam Lang came out, and we built some Johnson Sue bioreactors to get into the, it's a quorum sensing bioinoculant, quorum signalling bioinoculant that we want to create, and those fermented for about a year, and the background photo there is a microscope slide shot at 400 times magnification, showing spores and all sorts of things that are in there, and it's a wonderful product. It's not about nutrients; it's about quorum signalling compounds, enzymes, all those byproducts of the decay. there's just as a wee example, a commercial example of the large use of Johnson Sue in the UK is the G's Grower Co-op. So there are 15,000 hectares, vertically integrated, 9,500 employees, 720 million pounds of income, produce 1.2 billion individual vegetable plants a year. So very intensive vegetable production. And they found that using Johnson Sue increased the head size by 20% and made their soils easier to work and less susceptible to damage as a result of the severe weather. So they now have a shed with, I think, 400 Johnson Sue bioreactors pumping out material which is then just extracted and both root dipped and sprayed on soil applied at harvest time. So that's just an example of, a very bottom line focused business taking on a natural bioinoculant because it makes sense and because it adds up. I mean, it just pays the bills. So, I don't use Johnson Sue, strangely enough. We don't have a place for it because we don't till and we have animals on the farm. So it's not, the benefits for us aren't really there. And it's certainly the most dramatic benefits seem to be, or the effects seem to show up in depleted soils. So the left and right slide here, when we first, a few years ago I built a sprayer using Steve Erickson's Chaos kit, but I wanted a 3,600 litre sprayer, not 1,000 litres, so we built our own and bolted his kit onto it. But I played around a bit with how we put foliar feeds on, and it's quite important. The photo on the right was a sort of a first attempt, and you can see, I don't know, you may or may not be able to see that the material that we've applied is just sitting there bubbling on the leaf, and it's not really spread across the surface. But now this other photo was taken in the middle of a very wet winter, and you can see the plant's got all sorts of deficiencies because it's been sitting in water for so long. But it's also got a good coating of our liquid brew that's gone on, and that would contain fulvic acid, molasses, fish hydrolysate as chelators essentially, and then we'd add the minerals. I'm a conventional farmer essentially, so we still just add the sulfate forms of manganese, boron, or whatever we're using, and then we put the biologicals in last, which is EM generally, because it seems to be, in our system, it's been the most effective. And what we've learnt from that is don't apply copper and boron together. They tend to burn. Maybe different in a biologically chelated, lactobacillus brewed fertiliser brew. I don't know. And don't spray in the heat of the day. So the other things we do, I've built the compost sprayers on the left, and that shows the nozzle at the bottom. And then my seed drill, which is a 6 metre no-till machine, I put a liquid injection system on it, so we can put biologicals down the spout, in with the seed, and that whole system was built for about $1,000. So the injection system, which consists of a pod, a 12-volt spray pump, a bilge pump in the tank to keep it circulating, some 20mm plastic hose, and then some 4mm air hose, and then some 2mm air hose. And one of the photos there with the blue hoses is a manifold that distributes the product, and then it goes down the bottom. The other photo next to that shows the little hose running down the seed tube, and that's then just putting it in with the seed as the seed comes out the bottom. So that gives it a nice coating, and we've had terrific results with that. The photo in the centre shows blue peas that were planted, and the plant on the left was bare seed. The plant in the middle had bioinoculant X, which I won't mention the name of, and the one on the right had EM and molasses. And the one on so the bare seed crop yielded 5 tonnes to the hectare. The other commercial bioinoculant 4 tonnes to the hectare, and the EM and molasses 7 tonnes to the hectare. So we had a pretty good run with that. And then the photo in the top corner is just Phacelia and linseed growing side by side because it's a pretty photo, and they all had bioinoculants. You will have probably all heard of the soil your undies way of finding out if you've got a healthy soil. Just over Christmas, we've been trapping possums around our house. We've got 80 over the summer, but the bottom right-hand photo there is a possum that was deposited on the paddock, and that's 10 days after it was deposited there, so it's completely dissolved essentially into the soil. So that concludes the farmy bit of my talk. Yeah, so, sorry, oh yeah. So any questions for any of us? Oh, that's good. Sorry, what was the waste? Oh, so the question is anybody using abattoir waste as a liquid fertiliser? Is that correct? Oh, as the basis for... I'm sorry, I don't know. Do you know, Bridget or Henrietta? Yep, so they are from the rumen. Yep. There must be people who are eminently more qualified to talk about Johnson Sue than I am. David Johnson, University of somewhere in southern US, and he came up with an idea of static aerobic composting, which is pretty much the same as what Kay Baxter was doing by the sound of it with her cakes. Yeah, so it's an anaerobic static composting. So it's pretty good. University of New Mexico. Thank you. Anything else? Yep. Do you want to do the...
Yeah, I think we do. I mean, something like Johnson Sue, you can you just Google it, ChatGPT it. If you don't like that, you could look at our website. There's lots of people doing it. It's something that all of you can do at home, but you've got this. There's lots of ways you can be tripped up. You know, rodents can get into it if you don't water it properly. But if you follow, if you follow the instructions on, and they're quite simple ones, you can get a very fungal-dominated compost pretty easily, but you just have to keep an eye on it. Don't just leave it in the back shed for 18 months because it may not look as it should. It's the land gardeners, landgardeners.com. Yep. Yes.
Yeah, that's a good question. Yes, so the question is, do we get bacterial dominated with cropping? And the answer would be yes, we do, because we're always interfering with the soil. So it's always a sort of starting again from zero, and that's where no-till really reduces the impact initially. The use of cover crops and livestock are all things that we do to mitigate that and try to push it towards a more fungal system, so that it's not completely, because as soon as you get bacterial dominated, all the plants, which we call weeds, associated with that type of soil, they start the primary colonizer plants are stimulated to develop, and that's when you get your severe weed problems. So always trying to create more of a fungal situation is a key focus of what we do. So that's. Well, the sheep are fungal inoculators. The diversity of the plant species we use in the cover crop mixes, using a mix of legumes and oats. Oats are marvellous. We don't use rye because it's so persistent in our soils. We can't get rid of it. So that's those are ways we try to manage that. I mean, interestingly, we've increased our soil organic matters over the last 50 years from probably around about sort of 2 to 3% up to 10 to 12%. So we're gradually accumulating carbon, but I think we started making the most progress when we got a bit smart about cover crops and the intercropping season.
Yeah, and on a garden scale, I mean, what we do now is when we're walking around the garden, we always have our pockets full of seeds. And whenever we see bare soil, you throw them down, throw some phacelia down, throw some buckwheat down. And it's amazing how it not only covers the soil, it keeps the moisture in, it feeds the soil, and it's really your friend. And it's beautiful. The insects love it as well. So, aerate your soil, feed it with whatever you got. Maybe it's your coffee grounds from your morning coffee. There's EM all over New Zealand. You can get EM, which is environmental microbes. Go and see the guys at the biodynamic tent. I mean, honestly, if you do some like one of those, there's a preps that you can do, just 500 exactly. If you, just do it twice a year, and you will see that energetically your garden or your land is just going to come alive. I promise you, it's magical and it's wonderful and it's real.
It is.
And it's living, exactly. Living things. So, and also a lot of it's about you noticing things. It's a little bit like what John said this morning. It's about you noticing what's coming along, all the different insects and birds and bees, and how you are connecting with that soil. But however you can do it in whatever situation you have and what you have to hand, and I know that sounds sort of wafty, but that's where you can start. And then there's lots of people around, especially in New Zealand, that can help you get to that next level, whether you're a gardener or a farmer. We mentioned some of them today. Brilliant. Any more questions? I think now, just for a minute, I think Simon's got a little bit more, something really interesting that I think all of you, as Kiwis in the room, are thinking about, or should be thinking about. And that's many things that are going on in this country at the moment, but one of them is the Gene Tech bill, and I know all of you have probably got a view on it, but I know Simon has had some really interesting information on it, so he might want to just share that with you.
Yeah, thanks, Bridget. Don't mean to break everybody down, but I think it's just really important in terms of the future of biological agriculture and the survival of farming generally. I think, you're dealing with a technology that's very primitive. Miraculously, it's got all the answers for everything, even though it's, only been around for 5 minutes. And the technology, personally, I don't have a problem with technology, but I don't really want it released into the environment at this point. So my son, Charlie, who's just finished a Master's in International Relations and Diplomacy, did his Master's project on our market relationship with China, and more specifically looking at the fact that China has a food security policy. And Lord knows, if New Zealand had a food security policy, we might look at the way we do things differently. And I know this is at a high governmental level, but it would tell us, give us some direction about how we treat our land and how we plan for the future. And there's just nothing. It's a complete Wild West. So he's written out a summary here of what we've come up with. But I think the key points are that in 2019, an MPI report states that New Zealand's brand is a safe food source where all dairy is GMO-free, sourced from free-range grass-fed cows, would help with our market access to China. So that, I guess, in bureaucratic speak, is a very strong statement. It may not sound that way, but when you're a bureaucrat, that's quite strong language. And China has a policy of, doesn't have a policy of isolationism like some other large economies do. They want to selectively import high quality, reliable, trustworthy food from around the world. And New Zealand is sitting in an absolutely perfect position to do that. And now along comes this piece of legislation which makes me just incredibly angry, and I'm sure I'm probably not alone, that this access to a market, I mean, New Zealand can't possibly consume all we produce, but this access to a market has been put in complete jeopardy just through a few people who want to make a few bucks. So that's just, that's a value judgment on my part. But, you look at in China, there's actual there's research to say that the GMO has a negative correlation with customers in China. They don't want to buy food. In 2023, Environment Developed Sustainability did a survey. 60.8% of Chinese consumers surveyed said they would not buy food linked to GMO. So, we let it go here. Where do we sell our stuff? Because we've lost our priority access if that happens. So, and... Sure. Yep. And there's a ministerial statement from the man in question. So, I just wanted to share that with you, and I think it's, it's looking at the GMO thing from a whole different perspective, that from a business idea for New Zealand, it's a really stupid thing to do. And no.
Simon Osborne for Parliament.
Thanks, everybody. Thank you.
Thank you.